Okay, so we're on to our last speaker of the evening. Cal Henderson built the original version of Flickr on his laptop as an extension of his t-shirt management software. And I think it's come full circle now, and he now manages his t-shirt collection on Flickr. And Cal's going to be telling us in no uncertain terms why he hates Django. So please welcome Cal Henderson.
Hey, how's it going? Thank you. All right, I realize it's the end of the day, and it's a day that started really early, especially for those of you who don't live in Mountain View. So hopefully this won't be too taxing on the brain. I'm going to speak slowly because I'm quite tired. But, hello, my name's Cal. I'm generally a happy sort of person. This was me a couple of days ago on holiday in Hawaii, which I cut short to come to DjangoCon, so I'm fucking overjoyed. This is my happy face. All right, so who am I? I'm also known as Bees. I'm a user on Flickr. Hands up if you don't know what Flickr is. OK, Malone at the back. So Flickr is basically a website for sharing photos of kittens, for tagging them, categorizing them, figuring out where kittens are on a map, where they are over time, stuff like that. It is, as Simon says, an extension of my t-shirt management collection. If you go to flickr.com/bees_shirts, I think you'll find a reasonable version of my t-shirt archive. OK, so I work for Flickr. What do I do? Mostly I write PowerPoints at this point. But in reality, I'm an engineering manager, and I run the engineering and operations teams for Flickr. So Flickr, website on the internet. We have over 2.8 billion photos. That's a lot of photos. It is a lot of photos. That's 1 per 2.3 people on the planet, more or less, or 9.2 per person who lives in the US. So imagine if everybody took 9.2 photos and uploaded them on Flickr. That's where we are now, and we're adding them at an incredible rate. We serve, when it's a particularly busy morning, 35,000 photos a second. So it's like 1, 2, 3. Since I've started, we've probably served like a lot of photos. So this is more than 2 million photos a minute. So that's quite a large amount of stuff. Okay? So Flickr has photos, serves them on the internet, a lot of stuff. We have many thousands of pages a second that we serve. I'm not sure how many there are. Also, I'm not sure if I'm supposed to talk about such things. So there's more than 1,000 and less than 1,000,000 a second. But we serve a whole bunch of pages on the internet, really fast, big scale, all that kind of interesting internet scale stuff. So I'm kind of a scale nerd. When I started working on Flickr, I didn't really care about things like that. I mostly cared about, I don't know, I can't even remember. It was something else other than scale. But now I'm only concerned with scale. And like, I have a book that has a fish on the front of it that's mostly about scale. So maybe you'll understand where I'm coming from when I make a bunch of points. So Flickr is written in PHP. PHP is a serious language. It's like a proper programming language for grown-ups. Now, these 4 websites are in the top, in the US language, they're in top 15 sites on the web for traffic. Globally, they're in the top 20. Yahoo, WordPress, MediaWiki, Facebook. Yahoo is still the biggest site on the internet, Google, and it uses PHP. Okay, so PHP is a serious language for serious grown-up projects. Also, it's the kind of language of Web 2.0. So, Dig and Delicious, which are big sites in their own right, also use it. So PHP, good. Now, Flamework is the name of the framework that Flickr uses. It's a serious tool set. So it's like a serious set of framework stuff for serious applications on the web, if you're being serious. I think you can see where I'm going with this. You might be confused by the name Flamework. We have a naming scheme for things at Flickr, and it's quite difficult. I might explain it in a moment. We have things like Flamework, Flint, Flinderbox, Flawks, Flag, Flink, Flotos, Flictionary, Flops, Flenge. The key here is that what we've done is we've taken words and we've put FL at the beginning to make them into other words. Seriously, Google ripped us off with this, but they've only taken the G bit. Because we've taken 2 letters, it's a more kind of serious thing. These are all, like proper grown-up tools. So, why do I hate Django? I've said in my slides, I hate Django. I'm here to talk to you about how I hate Django. In fact, what do I even know about Django? This is the application engineering manager for Flickr. He doesn't know anything about Django. That's a hat somebody wears each day, depending on what they've been working on. So what do I know about Django? Why am I criticizing it? I'm just some guy who works on serious things and is up here talking about your wonderful framework. Well, I kind of have a little bit of experience with a little web app called Pounce. Hands up if you know what Pounce is. Yeah, OK, so it's written in Django. It's all fancy. And it's a web app that I have a little bit of experience with the code on. So I kind of know what Django does, sort of. And also, like everybody else on the fucking planet, I'm working on a blogging engine in Django. Hands up if you have worked on, are currently working on, or are planning on working on some kind of blogging engine in Django. OK, wait. Hold on. Stick up your hand if you're not working on a OK. Why not? OK. So why all the hate? Obviously, I care about it enough to write a blogging engine in it or start one. Why all the hate? So here's a scientific graph I've prepared. Hate everything a little bit. It's kind of in my nature. I hate some things more than others. I may touch on that point again later. I hate Django somewhere in the middle of these things. So let's not imagine that it's the only thing I hate or I really hate it, but there's a certain amount of hatred to be had. So my talk today is going to take the form of it's going to be split into several sections to talk about the things that are wrong with the thing you pretend to love. So first, I'm going to take the really easy ones, which are obviously a huge problem. The team, Python, and frameworks in general. And then later I'll actually talk about Django itself and talk about performance, scalability, maintainability, which are like the three key things to building large, scalable, maintainable web apps. And then probably some other stuff at the end. Obviously, the most important thing is the first section. So, the team. Now, this is important. Okay, you can't have a good framework without a team that builds it and promotes themselves and maybe starts a religion in Chicago. Frameworks are serious business. Like all of the big websites these days are built on frameworks, whether that's a publicly available framework or a framework that a large company like Google builds internally, a set of tools and a set of practices and a set of interfaces that allow them to build applications quickly and with less mistakes and stuff. So frameworks are proper serious business. Like people use them. So struts, there's a serious framework. Hands up if you use struts. OK, it's like 3 of you. How did you sneak in? Now, this guy is Craig McClanahan. He is the inventor of struts. And how do you know struts is a serious framework? How many core contributors to Django have a serious beard? 1. 2? That needs a bit of work. Now, this is how you can tell struts is a serious business framework for serious people with serious beards. Okay. But struts is for suits. Struts is for these large corporations with millions of people who have huge budgets and are building big, boring applications that we don't care about because they don't have rounded corners, they don't have Ajax. Who gives a shit? Okay, struts is for suits. But struts isn't the only other thing out there. Rails is the hot shit. I read this on Dig. It's true. Rails is what people build their frameworks on. And it's all about the team. Now, fucking Rails. Rails knows how to do this. Fucking Rails is badass. So, in comparison, okay, we've got struts, serious business. Rails is pretty cool. I think you'll agree. Django. I think I have these guys' album, actually. Seriously, that was the inspiration. Simon doesn't like people to know this, but his nickname is Stinky or Stinkles, and he does prefer to answer to that. So if you could let everybody you know in the Django community be aware of this, that would be useful. All right. So obviously, we can't take Django seriously yet because the team neither has the beards nor the 80s hair. Work on that. Python. Python is a programming language, and it's the basis of Django. Okay? What's the problem with Python? Where to start? So Python is kind of trendy right now. Like Google uses it. Oh my god, if Google uses it, it must be so cool. So Python is pretty trendy. The thing is, it's not that trendy as languages go. It's hardly Ruby, is it? It's not Haskell. It's not Erlang. It's not even Scala. And Scala is so cool that nobody knows it. Hands up if you know Scala. Liars, liars. Now, those are properly trendy languages. OK, but what does Python have going for it? Significant white space. All right. Now, the way I feel about significant white space is you either have to do it right or do it not at all. So one reason to do it not at all is this awesome program in one of the best programming languages ever called Perl. Can anybody tell me what this program does? Quickly? Quickly? No, it doesn't output itself. God. Do none of you know Perl? Jesus. Actually, this solves Sudoku for any size grid, for any combination. You just feed in the string of the grid, and it gives you out the solution, obviously. Python, I don't think you can do that. Python code is not actually pretty. Perl, serious programming language. But I figure if you're going to do white space, you may as well do it properly. Who knows what the greatest programming language ever invented is? It's not brainfuck. It's related to salmon. Visual Basic. Visual Basic is more of a framework, not a language. Otherwise, it would totally fucking be in there. So this is a program written in a language called Homespring, which is the best programming language ever invented. It's all about salmon and rivers. So this is a program. Now, white space is significant. And you might notice on the last line there, there's a whole bunch of spaces. I think there's 5 there and about 3 there. And this matters. It's also a poem. So this is one of the easiest ways to do Hello World in Homespring. It's a very efficient language. So basically, the white space in it dictates how a series of lakes and rivers join together to create your program's environment in which fish spawn and swim around and swim out into the sea or stand it out, and eventually die. This is a proper programming language with significant white space. I mean, why use it for indentation when you can use it for the flow of rivers? So this is proper. You can say a programming language like Python doesn't have things like quantum superpositions, which are going to be in Perl 6, and really cool things like, not closures, what's the next one up? Continuations, and things that basically only make programming language designers cry, and nobody else is ever going to use. So whatever. Python's OK with the stuff it has. But this is unforgivable. This is like the worst thing ever, because I can never remember it. And it's obviously just backwards. This, for everything else that's got going for it, this is the thing I have against Python the most. Also, mod Python, restarting a server when you change some code. Seriously, what's with that? And yes, I haven't done any Python for about 10 years, and I know that nowadays you have whiskey reload mechanism or whatever it is, and you don't have to do that. But I will pretend that you have to restart the server every time you change anything, and thus, ridiculous. This is a quote from a developer on my team who uses Python. A serious quote. I buy my eggs at the cheese shop. Nowadays, it's called the Python Package Index, I think, or PyPy. But who knows? Does anyone understand this quote? Yeah. Moon language. A serious programming language does not have a cheese shop in which you buy eggs. That doesn't even make sense. A serious programming language would have an egg factory which produced egg objects. Also, what's with this? I create a Django app and things like ugly warts of the language, like underscore underscore import underscore underscore, for doing the things that go on behind the scenes. And from future import stuff, I don't even understand this. That's not my fault. It's Python's fault. So basically, Python, a language for hippies who are scared of real OO languages. OK, so obviously, what's the plan for moving Django to PHP? Is that before 1.1? Presumably, it's quite soon. They're working on it. Jacob says he's almost done. OK. So frameworks. What's the problem with frameworks? So Flamework, the thing we use at Flickr, is a framework, or I've pretended it is. What does that even mean? So the idea of a framework is, the idea probably should be, to make common tasks faster, easier, and error-free. If we're doing the same things over and over again, as we saw when Jacob or Adrian, definitely one of them, showed us the code from the very early Django, it was like template stuff doing the same thing in every class. So the idea of the framework is to cut out that crap the boilerplate that we copy and paste, to make sure that we can work faster and we're less likely to make errors. That's cool. So on Flickr, we might have a bunch of common tasks which we perform over and over again. So those become, a library function or part of the framework or whatever. And that means that we can do these things quickly and easily, and we don't make mistakes that could be potentially dangerous. So what we tend to be talking about here is frameworks that operate on the frontier of many-tiered architecture. So this isn't, like proper grown-up Java computing where you have like n tiers and n tiers. So we're mostly talking about, get a bit excited. We're mostly talking about frontier frameworks. And the role of the framework there is to act as glue between a whole bunch of components. Here is an imaginary website. So the framework is all the stuff that kind of sits in the middle and glues together all of the other pieces. OK? Everyone agree? Yes, good. So framework is the stuff that sits in the middle. Frameworks are generally, as a concept, great for getting started, but perhaps slow you down later when you have to kind of understand what's going on in there. Malcolm's talk, I'm not sure he understands what's going on in there. There's a lot of stuff that happens inside the ORM, which is the correct way to pronounce ORM, by the way. The ORM has many things going on inside it, and it is complicated. What's it doing? When it's slow, what's it doing? So, but the interesting thing about frameworks is how they help development time, because you can do things quickly. So this is another very scientific graph. And the red line represents how fast you can develop a web app when you're not using a framework, when you're kind of starting from scratch with a language. Presumably you have a web server and stuff. But you're like, totally going to build a website. It's going to be amazing. It's going to be like Flickr, but for puppies. And you start out and you use your language of choice, and it looks kind of like this. And as time goes by, you get faster because you build up your framework and stuff. When you build it with a framework, it looks something like this. Stay with me here. It's really easy. It's amazing. You go really fast, and then you hit some kind of stuff, and you're not quite sure how to do it in the framework, or it's difficult to do, or you have to start breaking out of the framework into doing it in regular code, and then you start building your own kind of framework on the side of the framework for doing the things which you commonly do that the framework doesn't allow you to do, and then in the end, you get just as fast as anybody else. But this makes frameworks look like they suck. Realistically, it just doesn't matter. Realistically, frameworks make your life easier if you're building small to medium to fairly large things. They're generally a good idea. But it depends. Picking a framework, you need to worry about what the priorities are of that framework in general and its existence and where it's going. So, it's unfortunately, I've put 4 things here instead of 3, but like fast, easy, scalable, flexible, pick 2 or 3 or 1 or something. You can't necessarily have all of this in one thing unless you use struts. This is fucking awesome. OK, so different frameworks have different goals, obviously. Large scale is not necessarily a good goal to have for a framework. Most websites on the web aren't in the top 100 trafficked websites. It turns out all but 100 of them are not in the top 100. And ever since we had more than 200 websites, that's meant it's more useful to worry about the smaller end. It turns out skyscrapers are a little bit special compared to regular houses. Regular houses don't need 10-story foundations. In fact, you just build them without any foundations. What's with you, America? In fact, hands up if you've heard the story of the three little pigs. Yeah, it's like a children's story or something. Why do you build houses out of sticks? You're supposed to build houses out of bricks. So I was trying to figure out why this is. And I thought maybe there's not a large native wolf population on the West Coast. So like the actual problem of being eaten by wolves isn't so much of a problem. Turns out earthquakes. I'm not really sure. There's no metaphor here, but that's just why houses seem to be built out of wood. And that's useful to know if you're not American. OK, so everything I'm going to talk about from now on onwards, about features in Django and frameworks and such, everything I'm going to talk about as a needed thing is possible. Because Django is obviously a framework with a programming language underneath, and you can just drop down to Python and do whatever the hell you care. So everything here is possible. But the idea of the framework is to make things easy and fast, and to make us make less mistakes. So when I say Django should do X, there's no point going, oh, but you totally can do that, because you can just get a DB cursor and then do whatever you want. I realize this. But it would be nice if Django did some things for us a bit better. OK, so here we go. Let's talk about large scale and how framework can support things at large scales. So, shut up, I know it's possible. Django doesn't have easy support for multiple different database clusters, and that might just be different database servers. Okay? There's no super simple way to do it, because out of the box it assumes you have a database server, because most people do. So that means you can't do manual partitioning. Manual partitioning, really easy way of breaking things out. Say we have a whole bunch of tables, and a bunch of them are related to storing photos on a photo website, and a bunch of them are related to recording what you had for lunch. This happens in a lot of web apps, obviously. So these tables are completely unrelated, so we can stick them on different database servers. We never join between these tables. And we might be interacting with them on completely different parts of the site. So that's cool. We can stick them on different servers, and we can get capacity increase. Okay? We might have twice as much capacity now. That's a really easy thing to do. More complex than that is no support for multiple hosts per database, or multiple hosts per database cluster. I'm not sure if it's a trick photo or if they're twins. I know that's what you're thinking. So imagine we had a simple master-slave setup in database of your choice, which is probably MySQL if you've got any sense. Postgres kids. Where do we read from? We have a master and a slave. So with master and slave, we make all of our writes to the master. We can read from the master and the slave. This is something we have to worry about if we create a couple of connection objects and do the manage whatever things that they told me about. Where do we perform reads from? How about if we have a whole bunch of slaves? Where do we perform reads from? This is stuff that we have to worry about if we start to add slaves into a Django app right now. And what do we do if the master breaks? How do we deal with promoting masters and reading from the right place and writing to the right place? That's all stuff we'd have to handle kind of out of band right now ourselves, because it's not in core. Fair enough. The thing we care about here is often rewrite consistency. So the word which I'm most scared of, and I can't even look at it on the screen, is lag. So replication basically means we perform a write to the master, which is the red disk on there, and it gets replicated to the slaves by replaying the SQL. This happens through by asynchronously sending a list of everything we've done on the master, or anything we've done that performs a write on the master and performing it on the slave. Now, lag is the idea that we perform something on the master and it happens on the slave sometime later. It might be a few milliseconds later. It might be a few weeks later. It's likely to be a few milliseconds unless something's seriously messed up. But depending on the environment between master and slave and stuff, we can end up with lag. So, lag, again. It's bad for a number of reasons. So say we were saying we'll perform all of my writes to a master and all of my reads from the slave. And I go onto the website where I want to enter what I had for lunch. And there's a form. It uses new forms, or new forms when it comes out. and I put in, for my lunch today, I had some kind of lasagna thing, but it was free, so that's good. And I hit save, and it saves and takes me back to the list of things I'd had for lunch, and it's totally not in that list. That's because the write is still being replicated from the master to the slave, and so I type in what I had for lunch again, and I type it slightly different this time, and it's still not there, so I keep typing it again and again, and then I lodge a support ticket. And somebody comes around, looks at the ticket, and says, oh, but you've totally put what you're having for lunch 3 times. You can see the problem. So what are slaves really good for in the simple case? Things like non-writing users. If users logged out, they're not going to perform any writes. Stick all of their reads on the slave. Okay, that's really simple. Non-time sensitive data, like feeds or read-only APIs, we stick that on a slave to move some of the work over to a different database server to allow scale. This should be something, could be something that's very easy from the Django side. We could say, I don't know the right terminology, but one of those query set master thingies with objects. You could say, this is not time sensitive. I don't worry about this reading. I don't mind this reading from the slave. And then pick a slave that's up. That'd be cool if it did that automatically. It'd be kind of useful. All right, I haven't had any pictures for a while, so this is just a kitten break. OK, more diagrams. So master, slave, wonderful. Turns out most of the people using like MySQL these days, for high availability worries, we use master-master pairs, which are a pair of boxes which act as each other's master. And so you can write to one, and the write will go over to the other, or you can write to the other, and the write will go over to the first one. And they remain vaguely consistent, but with that whole lag thing going on. So this is fairly cool, because if you go back a few slides, there it is. What happens if the master fails? We get into a weird situation, like where do we put the writes, and what happens? It's not terribly interesting. But with a pair of masters, it doesn't matter, because we can write to any of them at any time, kind of. So happens to be what the cool kids use. The problem is we still have the same consistent rewrite problem. We write to side A, we read from side B, then replication occurs. We haven't got the right data. It's just like when your lunch has disappeared. It's bad. But if you make sure you do something like write to side A, then read from side A, then something, profit. Totally makes sense. I mean, a method that lots of people use, certainly that we use at Flickr, is that we hash a particular user, kind of, to one side of each pair. And we say that all of your reads and writes will be performed on this particular server, so you get a consistent read-write state. That's kind of a simplification, but it's enough of a lie to make sense. So it would be nice if Django would do that for us, somehow using magic. And then in the case where the box that we're supposed to be reading and writing to dies, we read and write to the other one. The world's a good place, and we continue to know what we had for lunch yesterday. And then you can start to get fancy with like masters, which have slaves and stuff. And there are many different reasons why you want to do this, and they're all covered in books which are obviously far too technical for people who don't use Java. But whatever. We can get any kind of fancy arrangement of multiple multi-level trees and masters and all kinds of fun stuff. But we shouldn't really have to care about the particular setup of our thing in our code. We should just be able to say we want to perform writes, and we want to perform reads, and we want them to go to the right place, and we want it to do the right thing. We want it to fail over in the right ways. It'd be nice if we could just do that with like a module, whatever you call them in your language. It's all about where do we read and write from. So really what we want, this is kind of a made-up part of Flamework that to perform a database query. It's abstraction. We just say what particular cluster of databases we want to operate on in the SQL, and it figures it out. Figures out, are we trying to do a write? OK, send it to the masters. Are we trying to do a read? Are we trying to do a read in a context where we don't really care about the timeliness of the data, and we can deal with replication lag? Are we in a situation where we can do that? Have we already performed writes on this page, in which case we probably want to read from the master? Stuff like that. So it's all abstracted away behind a hideous, hideous function written in PHP. So you could write your own hideous one in Python. So this is a biggie. Or maybe it's not a biggie. Maybe like nobody actually cares about this, apart from me. But there's no sharding, automatic sharding in Django. So what's sharding? It's all about books. It's not really. But this is a good analogy. I just made it up yesterday. Who's familiar with the Dewey Decimal System? What is it?
The library thing.
That's really good, Simon, the library thing. Anybody other than Simon can tell me what it is. Yeah, it's a way of cataloging books. It's a way of like listing books in a particular order. Like all the computer books go first. I've never really paid attention to anything after 001, but I think it's like psychology or something. Okay, so it's a way of ordering books. So it's kind of useful, because it means you no longer have to have like one massive shelf of books in alphabetical order. So there's a way to break them up into sections, so they're in logical sections and they're easier to look through, because if you want to find books about the moon, you go to number 174. It's totally the right code for the moon. So you can go straight to the shelf that says 174 on it, and it'll be books about the moon. This is good. But it can't do everything. What if you decided, actually, what I really want is books with a blue spine? Now, there isn't a Dewey Decimal code for books with a blue spine, because that would be stupid. But what if you did want books with a blue spine? You didn't really care what they were about, and you wanted them to be about yay high, and probably with about 100 pages, and you'd like them to be quite thick pages. Where would you find that in a library? Ha, see, I got you. No, they're not in the moon section. OK, so the idea behind sharding is, if we have a very large data set, what's a useful way in which we can split it up into chunks where we can find things later? Not just we can find things later, but we don't have to have a shelf that has an infinite length. It turns out it's difficult to build shelves with infinite lengths. And lots of people write books all the time. This is a metaphor. So sharding up your data, as, say, we do at Flickr, we happen to have a long list of photos, and we can't store them all in one database table, unless we're using like Oracle or something amazing. So we need some way to cut it into chunks, and we happen to do it by the person who owns the photo, and some other ways too, but mostly the person who uploaded that photo. But this does make some things impossible. That is, if we've cut up our books by Dewey Decimal code, how do we find all of the books with blue spines? It's not impossible in the actually is impossible sense. It's just kind of dumb, because what we'd have to do is shard walking, or we'd have to go and look on every single shelf and try and find all the blue books. And it turns out that takes longer than going to a single shelf to find some books in a row. Okay. But what I really meant was database records. The whole time when I was saying books, I meant database records. And shelves were like servers. Not sure about the color. So it turns out doing sharding in a general purpose way is a fairly difficult thing, like it's a properly difficult task. But Django knows our models. It knows the models and the relationships between data, and it sort of knows how we query them. It doesn't, but we could tell it. And so it should be possible to do this on at least some useful level, if we accept certain constraints. If we say to Django, this is our data model, and this is the way in which we're going to query it, and we promise we're going to query it in this way. So we're always going to have filter by this certain criteria. For instance, if it was photos, we're always going to know who took the photo before we want to fetch it. And so Django can say, I can be smart about this. I can use that as the key to split stuff up. I can use that as my Dewey Decimal system. And I promise never to look for photos by color. Or at least if I do, it'll be my problem and not yours. So sharding, kind of a useful feature of a system. Something else that you start to worry about once you get into master-master pairs and individual shards is IDs. So who loves auto-increment IDs? You all do. They're amazing. They're great, right? Because they just do stuff for you. You insert a record, and it has like an ID. And you don't get any collisions, because the database takes care of that. But what if we had like 2 different databases, and we're inserting what we had for lunch into what different people had for lunch into both of them? And I put my lunch over here, and Simon puts his over there. Can't believe he ate it. What's that? Shut your mouth. Can't cut ahead. The problem is, we both end up with lunch ID 4, which is all very well, until we realize that Simon needs to be moved onto my server because he's just not happy over there and he's feeling lonely. I'll let him. He comes over, but we have colliding IDs. That's no good. Okay. So what we could do is we could do something like Simon suggested, where the servers, like one of them generates odd numbers and one of them generates even numbers. And then what happens when we want to add a third server? Oh my God, that doesn't work anymore. So often with systems like this, where we need to insert data into multiple different databases and we need unique identifiers, we need some way to specify external sequences or have some kind of external thing generating IDs for us, and something that manages to generate unique IDs. So auto-inks can be bad in these situations. So we don't use auto-incrementing IDs at Flickr because that would be bad. We'd end up with photos with the same IDs. That would be very confusing because that's a part in the URL. Which one would we look up? It would be bad. Ooh, 1, 2, 3, 4, 5, 6. I guess that's why they took a photo of it. So this is a slightly easier one because sharding is a little bit nerdy. But there's no automatic denormalization in Django. I love denormalization. It's my favorite long word that I know. So everybody knows about normal form and like relational database theory and all that kind of stuff? Yeah, it's great. What's everybody's favorite normal form? You're such dorks. Yeah, so that one's quite good. But denormalization is terribly useful. And denormalization is taking a normal form database. It's not like throwing normalization out because it's all great and that's why they teach it. It's taking normalized data and denormalizing a bit of it. So say we have a parent child, or we have some kind of linking relationship, and we have a piece of data in the original. Well, let's have a concrete example. Say you had some kind of website where you sent messages to each other, and it was written in Django. Okay? So you have one table which has messages in it, and one table which has a list of messages to users, to say they're in their inbox, or whatever you happen to call it. It would be really useful, from a performance point of view, to copy certain fields from the actual table of messages into the linking table, because then, for a reason I'll talk about in a minute, it would be much faster and much better and allow you to do more sharding. So the simplest form of denormalization is stuff like counters. If we have a parent-child relationship between two objects, for instance, a user has a number of lunches, it might be nice to be able to cache that number of lunches in the user record rather than doing a count star all the time, because that count star is a little bit slow and gets slower as you get a massive data set. And Django could be smart about this, because it knows whenever you're adding a child, whenever you're removing a child, or it could be even more complex. You could say, what I'd really like is a count of lunches that were on Wednesdays and store it in the Wednesday count field. And then Django would know when you inserted one with a day of Wednesday, or when you took an existing one which had a day of Tuesday and changed it to a day of Wednesday, decrement a count, increment a count. Django could do that. You could say, I just want this kind of criteria denormalized into this field on this model. That'd be cool. And copied fields too, which was the example I talked about earlier, where you just want to dupe a piece of data from like a main table into a linking table, just because it makes queries faster. That could be kind of cool. It'd be easy enough for us to specify in our model that this is the foreign key relationship, and this is something we'd also like you to dupe into this table. Now, the danger here is if we ever operate on our database outside of Django and this data goes out of sync, well, that's what manage pi is for. It's like, say, manage pi, fix up the shit in this field, and it'll dupe it all, right? The idea behind denormalized data isn't that we throw away normalization, it's that we take our normalized model and we add some extra data on top. We can always rebuild the denormalized data and counts and stuff from the actual normal data. So that'd be a good thing for manage pi to do. All right, that's scaling. Let's talk about high performance. Who cares about performance? Okay, nobody apparently. So obviously the problem with Django is it's like totally slow. It's so slow, it's ridiculous. Here's a scientific graph. Doesn't fucking matter. It's fast enough. Beyond a certain point, everything is fast enough that it doesn't really matter. There are limits. So as I said, beyond a certain point, it turns out the HTTPD written in bash that uses netcat is quite slow. I wouldn't use this for serious production traffic, but like for small projects, it might be quite fun. Past a certain point, it doesn't really matter. Django is fast enough that all of your time is going to be spent in the database and on the wire anyway. Like, let's make it fast, but I wouldn't really freak out about it. Sessions in Django. What were you thinking? So there's like this extra database table which has a gazillion records in it, an extra read on every page. Lightweight is better. The lighter the session, the better. So we talked about swappable backends, so you can stick sessions in memcache, or so you can put sessions in local files. I assume the idea of that is to make things worse, to demonstrate that database-backed sessions aren't that bad. Okay, so you could put your sessions in memcache. That's cool. You can swap the backend. But how about even better? You just stick them in a cookie, which is what lots of websites do. Most of the time, the only thing you care about in your session is who's signed in. Well, how about you just put their ID in a cookie and sign it so that they can't tamper with it? Turns out then you don't need to do any database or cache reads for the common task. And lots of websites that are big on the internet, like Yahoo, stick an extra bit of like session data in there as well. If they need to, say, know your name to greet you on a page, stash it in the cookie. Right? You can stash a few hundred bytes of data in a cookie without it really being a big problem, especially if you put your assets off on a different domain so the cookies don't get sent there. So you can avoid the database or the cache read and write completely just by stashing it all in a cookie. That's good enough, because if they didn't have cookie support to begin with, they weren't going to be signed in anyway. Let's do that. Sounds like a good idea. Great, get on it. This is one. I don't know. This is a bit of a nerdy request. There's no parallelization. I mean, yeah, you have threads and all that wonderful stuff unless you're on App Engine. Parallelization, kind of useful. So say we might often do the kind of thing where we get a list of things we want to fetch from the database, and then we do a whole bunch of cache fetches. Say we're displaying lunches on a page, and we've cached each of the lunch records, with their identity thing, whatever that patch is that hasn't landed yet. We want to make a request for each of them. Say we have 100 lunches we want to fetch. Now, what we'll do right now is we'll make 100 round trips to the cache server. Turns out that's a bit silly, because that spends a lot of time going over the wire. What we can do is make multiple multi-keyed reads. We know that if we have like 5 cache servers, the most we're going to really make is 5 round trips. Okay? So we'll do a multi-keyed read to that server, to that server, and to that server. But really, we could do them all at the same time. And then we could do the whole thing in a millisecond. But it doesn't really matter when it's different between 1 millisecond and 30 milliseconds. Maybe when it's 1 and 100. That's not such a big deal. What it is a big deal for is things that are really slow. Don't know why I picked that photo. But HTTP requests, if you need to do some kind of external request, like for ads, that's why I picked it, because it's an ad. OK. If you need to do some kind of external request, for instance, for an ad, which might be slow, some kind of resource which is going to take more than a millisecond or more than 20 milliseconds, might take 200 milliseconds, it would be nice to say at the beginning of the page, hey, we're going to need an ad, and we're going to need to do this HTTP request. Why don't you kind of get on with that while I do everything else? And then once I'm done with everything else, I'll see if you're done. And then I'll put you on the page. That's kind of useful. That's something we use for especially external slow resources, like ad servers or like some third-party service which we know is going to take a long time. So it's like, tell us when that's done. It's all good. So the ORM, the dreaded ORM, creates kind of dumb SQL. I'll talk about the dumb SQL before the really dumb SQL. So this is something you do. foo.exclude bar equals true. Now, when it's backed, I don't know about other databases, but MySQL doesn't have a Boolean type. Okay, so it probably creates a tiny int, I'm guessing. Django does in the magical background. But when you do exclude bar equals true, it adds this to your where clause, where not bar equals 1, which is kind of like, yeah, it's the right thing. But unfortunately, really that means where bar not equals 1. So you're not doing a comparison anymore. You're saying, give me any other value other than 1. And it turns out you can only use that as the rightmost field in an index. You can't use it as a left-hand field because it's not a constant lookup, because it's a variable lookup. It's the same way you can't, I don't think you can do one like greater than, less than type thing in GQL, I'm thinking. So you can only have one rightmost part of the index. Same thing here. This is kind of dumb. I mean, the thing is, you can fix it by saying filter bar equals false, which does the right thing and then is indexable. But really, Django really knew what we were doing. When we say exclude bar equals true, it's the same as saying filter bar equals false, because one is the inverse of the other, but only if we're dealing with Booleans, which we are on that side. So that's just a bad bit of translation. That's fixed now? Good. It should be fixed. It was totally broken before, though. All right. So in my last section of things that are totally wrong with this framework that's never getting any development done on it and never has anything fixed, I talk about maintainability. But actually, I figured out when I was writing this that I have a whole bunch of other stuff that doesn't really fit under maintainability, so I'm going to call this awesomeness. And everything in this section is about being awesome. OK, so what is with the verbose template syntax? Look at it. So many characters. This is smarty. You've wasted 3 characters. In the time that you were typing those 3 characters, I made a dig killer. OK, admittedly, since you changed the way templates work and you do auto-escaping, I also have to add a little thing on the end. But still, I'm a character ahead. And if I turn on auto-escaping in Smarty, I'm still 3 characters ahead. I hope you're embarrassed. Who came up with the template syntax? So Stink, why does it have double squiggles instead of a single one?
Because single ones you might want to use, double squiggles are a bit more obscure.
That's true. No, I was just... I don't disagree. We just have a way around it in Smarty. Because we figure, you'll type more tags than you'll type bits of JavaScript to CSS directly into your templates. Fair enough, it's a design decision. It's obviously a bad one. Is there a reason why there's spaces?
They're not required.
OK. Style? Yeah. OK. Yeah, it's insignificant white space. OK. So the if things. So why did you go with the % here?
So we can pass the whole, so the template next to would be a single vector
No, no, that makes sense. Yeah. I like that. But so obviously, smarty, 9 extra characters, a Google killer, and I had lunch while you were typing a single if block. It's ridiculous. You should all be embarrassed. Okay. Verbose template syntax makes people cry. Every extra byte that you add is like an extra byte that you have to store on a server somewhere, and bytes cost money. Django is not an effective return on investment. It's ridiculous. You're just throwing money away. You may as well not use tabs. You don't even use tabs in your Python, do you? You use spaces. It's like you have money to burn. Okay. On a slightly more serious note, there's no query debugger. Well, there kind of is. There's this thing. Everyone knows about this thing? Anyone not in core know about this thing? So you type it in, and it tells you the queries that you ran on a particular page. It's not good enough. It's not good enough. There's this thing, which Pounce have on their development server, which they got from somewhere or other. It's kind of better. What it does is it says how many queries are on the page, how long it took to run it, and you can expand it, and it shows you a list of the queries. That's pretty good. Core should have something like this. It's good, but not amazing. Obviously, the amazing things are in Flamework. So here's some crappy output from a Flickr server that tells us all the kinds of things we ran. It's good, useful. It's almost exactly the same kind of thing that we get from that extension I showed you on this page. But it also shows us like memcache stuff and other HTTP requests and all that kind of good junk. And also gives us an awesome summary of everything we did on the page, like how many times we connected to new servers. We connected to multiple servers. Isn't it awesome? How many times we did queries, how many rows we fetched back. Can also show us like how much data we took up on the page in specific internal caches and stuff like that. This kind of stuff is useful. What are you showing me, Simon?
That's our query analyzer that does all that stack traces to tell you where each single query is pulled from. But I haven't released it, so it's cheating.
Ah, OK.
No, I've released bits.
That's terribly useful. Another trick that we do that's quite useful is, so the whole stack trace is telling you where it's called. We do a light stack trace, just find the function we're inside, and stick that as a comment on the end of every line of SQL we execute. So if you go to the SQL, this isn't in the slides, so I just thought of it. If you go to the SQL process list and look at what's slow, you can find out exactly who ran it and where. So there's a free one for you. Another cool thing you can do is make those queries clickable so you can find out more about them, like do explain on them to understand what they're doing, or have a look at the data they returned to see what data they returned. And you can do this as well as for your database queries. Why not show what you returned in memcache, or whether you managed to set a key, or what your HTTP request returned in terms of headers and body, and how long each phase of that took. Or you can do really badass stuff, like using the MySQL query profiler to tell you everything MySQL was doing when you requested that query. Obviously, there's quite a lot of data in this kind of response, and it's only for nerds. So this is like a mode 11 when we turn it up on Flickr for debugging. But it can be terribly useful, because you can see where you actually have accidental iterative queries when you're doing views, if you happen to use views in MySQL 5. So that's kind of cool. MySQL query profiler came in 5.1. It's kind of badass. One of the problems, yeah, OK, some of you know Steve. Obviously, a big problem with the Django community is they're not quite smug enough. In fact, they're quite nice, the core people. I figured out why. It turns out all of the smug on the internet is already being used. There's very little left to go round. I'm not sure how you can overcome this. I think you're basically just screwed. So, bitching about the ORM again. Seriously? What does that even do? I'll tell you what it does. It does that. Select star is fast. It is certainly faster than select every field name, because it's smaller data over the wire, it's faster for MySQL to parse, and it's easier to debug. I don't know why everybody in the world seems to be scared of select star. If the patches go in the future and it brings back a certain subset of fields, then it starts to make sense. But the other thing is, if you only have one table in the query, you don't need the table name in front of every field, because it turns out MySQL knows that you've only used one table. So you could just make that half as fast, even if you were using all of the field names. OK. Don't be scared of select star. It's there for a reason. It's there because it's awesome. And I mean, we have the same thing here, but we also have the problem of, tell me what that query does. Yeah. So this is really easy to transform if we just happen to be debugging, but it's much easier to read something like that. Part of that is that I formatted it using tabs. And those are tabs, not spaces. Tabs make things more readable. But also, I've picked table aliases that are really short. So that has two advantages. It makes it more readable, and it makes it a little bit smaller over the wire. It doesn't make it any quicker to parse, but it does make it much easier to read things by hand. I don't know. Maybe that's a mode you should turn on or something. So with the SQL outputs, Django makes me scared of joins. What even is a left outer join? I think that's made up. So I know it's not really. Django makes me scared of joins. But it turns out joins are actually evil. So Guido said this morning. You don't do joins when you get to a certain scale. It turns out joins are really evil. So it doesn't matter that it puts out SQL that frightens me, because you should never use it anyway. All right. Hey, Django 1.0 was released. You're supposed to clap. Take your time. I'm suspicious. I'm suspicious of things with low version numbers. Think how more awesome this would have been. That is a framework you can trust. Or, oh yeah, that is serious business. That's a framework I can get behind. Django is also suspiciously small, 105,000 lines of code, and it's like a universal framework. Framework only powers Flickr, and it's 2.5 times the size. And we use like nearly every line of that in Flickr. Like most of Django, you don't even use it all the time. So it's suspiciously small. But I think I figured it out. It has single, very, very long lines. The ORM is 3 lines. Obviously, the main problem with Django, what kind of framework can't pluralize octopus? Hands up if you don't know what I mean. OK, good. Get that sorted. Slightly more serious. Commit all fields at once. Commit all fields at once? Seriously? All of those fields? The like 5,000 we saw on screen? We get race conditions. We read in a bit of data. We modify one of the fields. Somebody else is doing the same thing to another field. We write back at the same time. We're operating on different fields, but we run over each other. It's a race condition. We should just be able to use dirty flags. We should be able to say, this is a field that we've operated on. We'll save the changes. Now, I realize. Don't make Malcolm cry. And by the way, this obviously was taken earlier today. Who took this photo? Hands up if you took the photo. You're not allowed to take photos in here. Oh, really? Whatever then. Who cares? But I think I have another slide. Oh, no, I don't. But it turns out there's a way to do this without, so the worry is if we have a very expensive field, how do we know that the value's actually changed? Who cares? If we try and set a value to it, even if it's the same value, let's imagine it's changed. That's already a big improvement, and we don't need to do anything other than store a bit mask for the number of fields that are in the model. It's not terribly expensive, and it's certainly better than the alternative. So if I update my huge text field with exactly the same thing, we're going to save it, but it's still better than if we didn't update it at all. So fairly cheap solution if you don't want to get too fancy. There's no simple way to increment and decrement counts that are in your data store. That's kind of silly. That would be a really easy operation. Turns out they did that in SQL some time ago. And you can do it as an atomic operation which doesn't have race conditions in it. So if you're going to be reading it, adding one to it in memory and writing it back, and somebody happens to be doing it at the same time, turns out they'll go out of sync. If we use atomic operations like that, they don't. Easy enough. Character encoding input validation. Who's familiar with the Google XSS hack that Chris Shiflett came up with about a year ago? The UTF-7 one. Now, does Django protect against that? I don't know, but it probably doesn't. It turns out most character encoding filtering is really complicated and barely anybody gets it right. And usually they get it right because someone finds an exploit against their site. I'm going to guess Django doesn't do it right. It totally should. And if it does, good work. I was totally going to research this. I didn't get around to it. Why does Django not have a mascot? You can't have this one. The narwhal is the mascot of the Flickr engineering team. Simon doesn't count. You need a mascot. I asked somebody yesterday, or the day before, what should be the mascot for Django? Django needs a mascot. Serious projects have a mascot. What's that? The one on my T-shirt? I think that's Twitter. Maybe an echidna? That's a pretty good animal. I don't know, maybe. Or how about one with magical powers? I could take a framework seriously that had a mascot with magical powers. So it's like, Django, magical powers. So, there's no kind of built-in deployment system for Django. A bunch of tools to help you, you've written your code, it's awesome. You want to put it out live. I'm not sure if Simon's nodding or saying, no, he's wrong, he's stupid. Capistrano, whatever. And it's like, often you want to extend your model. Tables never big enough. At least tables where you specify the fields first, obviously. Value stores, doesn't matter. Tables are never big enough. You always want to add things later on. When you change a model, who's done this? Manage Pi, reset app name. It sucks. It totally sucks, yeah. Obviously, what I want to do when I add a field to my table which has millions of rows in it is to wipe out all of the data so I can start over. This is obviously historically what we've done on Flickr. Anytime we want to add a new feature, we just delete all the photos. Keep a copy of them. That's my tip. I mean, this is changing. Django Evolution does it in an automatic way that I'm slightly suspicious of. Demigrations, Simon's thing that he released the other day, it's kind of awesome. It's definitely going in the right direction. It's, explain this is my old model, this is my new model, this is how it changed, and it's either a simple change or this is how it changed and this is how I want to migrate data between the two. And then you build a more thorough toolkit around that. This is how I want to migrate data, and this is how to do it slowly because I have too much data. And then you end up with a whole series of how to go from one version of the site to another. This is a good thing. Good thing. So, I ask you, what has Django done for you lately? Consider this question before you use it for another project. Thank you. I will take some questions after you've clapped. That's now. This is a lie. They're not online. I'll put them online later. Sure.
So is this what happens to my pictures of kittens when I sign the Flickr terms of service?
Every photo in this presentation, with the exception of the one of DDH, is licensed under the Creative Commons, and I'm allowed to use it in this presentation. Any other questions not related to any of the photos? I didn't think so. All right. Thank you.
So it seems like there's a natural tension between the fact that most sites aren't Flickr or Yahoo or Google, and the fact that, and for them, Django is kind of fine as is. And so, great, we're done. And then there's the tension between that and the sites that, are Flickr, and it would be really awesome if people, actually could build those things. So, and you had both sides of this in your talk, and I wonder whether you think that it's necessary that a sort of general purpose framework actually address the concerns that you brought up, whether you actually think that that's something that frameworks in general ought to be trying to do.
Sure. So that's an important question. The answer is, I'm not sure. I certainly do know what's wrong to do, and that's to build a framework which doesn't cater to any of this and then claim it is like the most amazing thing that scales really well. That'd be Rails. I mean, it's like, who knows? Who knows how many users of Django would use this stuff? I mean, some of the smaller stuff, there's obviously grades here. It's like probably quite a few people might find use in having master-slave database represented. Less people are going to be using sharding. Denormalization, some people, yeah. And again, like query debugger and like the more toolset stuff and obviously schema changes, that's stuff that everybody can kind of get behind. So I think it really varies. Some of this stuff just makes a lot of sense to be in any framework, even though it's more useful for large-scale stuff. And some of this stuff is probably just nuts. I would never do it. That said, if you want to kind of be badass, then maybe it's worth adding these things.
Just to address Jacob's point, I work for a very, very big company too that has,
You work for my company, don't you?
Yeah. No. Yes and no. You can do whatever you want. I can't. So basically, and we've done a small project in Django. Now, if I want it to be used even internally, probably I'll have to go through shitloads of reviews, and there's a good chance that simply because there's no outright support for multiple databases or sharding or whatever, there's no freaking way that my application can get out. And basically, I can't use Django at all because of this. So yes, it would be useful if some of these concerns were addressed, I guess, for some people.
I mean, having a little bit of inside knowledge, do you think it's more because it doesn't have these features, or just the fact it's in a language which we don't tend to use, and it's a big framework full of hundreds of thousands?
One, the language. Two, the features.
To those
the
issues?
language is the first barrier.
Yeah, I mean, that's interesting. Maybe addressing some of these issues would mean that it could have wider adoption in companies that care about this kind of thing.
Yeah.
But again, is that a goal of Django? I don't know. What is the goal of Django? To be awesome? Yeah.
No, but something like sharding, even when I think about my previous job for a small startup, sharding is something that we were doing as a small startup because we had a fair bit of data.
Had a large data
that
set,
sort
yeah.
of shit stuff,
Yeah.
sorry, is really, really, really useful. So.
Yeah, I guess that's the distinction between, I mean, haven't really talked about scale today, but the distinction in different areas of scalability. Do we want to handle a huge amount of traffic or a huge amount of data? Because if we're doing something that's quite small traffic-wise, but we're dealing with geodata, we might have a fuck ton of it. And that doesn't mean, and that means that we might need the tools to be able to handle that. Obviously, if you heard the GIS stuff earlier, we end up working with a lot of data.
I'd just like to suggest that perhaps Django's mascot is self-referential. Django's mascot is actually Django, but Django Reinhardt.
Yeah, I mean, I kind of see that, but he's not an animal and he doesn't have magical powers.
Oh, he kind of does.
What if we pretended that he had magical powers?
Now, see, now you're going the way of Rails and it's making a lot of sense. Okay, thank you.
Thanks a lot, Cal.